If you want to improve your development skills, and you want to reduce the number of bugs you ship to production, and you want to feel more confident in making changes to an existing code base, you should really learn unit testing. Today, I'm going to introduce the topic of unit testing and show you how to get started. We're going to take a small demo app and add tests to ensure that the methods behave as we expect them to. Along the way, we'll talk about best practices, how to rework your code to be more testable, and how tests make code updates safer. My name is Tim Corey, and it's my goal to make learning software development easier. If that sounds like something that interests you, make sure to subscribe to this channel. If you're interested in possibly buying full courses or hearing about insider information, make sure to click the link in the description to sign up for my mailing list. Now, before we jump into code, I do want to point out that I'm going to be using a third-party testing library today. Normally, I try to teach just what you get out of the box with Visual Studio. However, when it comes to testing, I think that XUnit has a lot more to offer than Microsoft's MSTest. XUnit is a long-running open-source project that consistently provides a great experience, and from what I've heard, it's only getting better. With that being said, if you'd prefer to use MSTest or NUnit, the techniques you find in this video will mostly apply. It's just the syntax will be a bit different. Okay, so let's start by reviewing my development environment and also the demo application I set up. So this is Visual Studio 2017 Community Edition. That's a change from what I normally do. Normally my development machine is 2017 Enterprise Edition. However, Enterprise Edition has a lot more features when it comes to unit testing. Now, that isn't to say that unit testing on Community Edition is crippled. In fact, it's a full-featured testing environment. It's just we don't have some of the niceties that add on top of unit testing in Community Edition. So I want to show off what everybody has access to. Because again, Community Edition is free at visualstudio.com. So make sure you go to visualstudio.com and download the 2017 Community Edition. Not the Mac Edition, not the Code Edition. And if you want to check out my 10 free tools video, you'll see more about which ones works for you. But get the full Community Edition. So that's what I'm on right here. And if you're wondering, I'm actually running this in Azure. I created a virtual machine today, spooled it up with 2017 Community Edition just to kind of show it off. So this is actually running in Azure, which some of you had a question about whether or not you could have an actual full machine in Azure or not. This is proof. I've got the full desktop. I've got everything here that you could want in a machine all in Azure. And it was spun up in about, I believe it took 10 minutes for this to spool up, maybe less. So, and this is a cheap one. I think it's $30 a month if I were to pay for it. So not that much, especially since I won't keep it running all month. I'll actually shut it down. This is just for this demo. Okay, so my solution has two projects. I have a library project where I have a person model, which is just a class with a couple of properties and a full property that's read-only. And then I have three classes: calculator class, data access class, which just does file access. So it's just reading and writing from a text file. So I want to do it that way so that when you download this code, and you can download this code by going to the link in the description, it'll take you to a blog post on my website. You can go ahead and download the source code. If you download the source code, then you can actually run it in your environment because there's no SQL database or anything else complicated. It's all self-contained. So then finally I have an examples with just, one more thing. Hey, I'm loading a example text file. And the reason that's there is just because I wanted to have the ability to sometimes throw an exception. We're going to go ahead and catch that and make sure that we get what we expect, which is, in the case of bad data, that we actually get an exception, not something else. So we're actually going to test for exceptions. So that's down the road, but those are our classes here. again, this is just for demo purposes. The application technically works, kind of, but the point is not that it works. The point is to show us some good examples of how we need to do different things in order to test an application. So we have a WinForm UI. That's our actual user interface. And we've got this right here, which is our dashboard. It does two things. We have a calculator over here, pretty simple. Number one, number two, you either add, subtract, multiply, or divide. The results pop over here. And then we have the database section here, which is just a list of people. And then if you put a first name and a last name here and say add person, they get added to this list of people. That's it. That list of people is actually from a text file. So we start off with, over here, the person text. There's our starter text. But what happens is this file gets copied to the bin directory every time I compile. And so we kind of start over with a clean slate, except for we'll have these 4 values in it to start. So that's, again, just a testing thing. I wouldn't do this in a production environment, obviously, because it would overwrite my data every time I recompile the application. Not a good thing. But again, if you're storing sensitive data or important information in a text file, you might want to rethink your application anyways. Okay, so if we run this, we should see that, yes, I've got a drop down with 4 people in it. If I add Bob Dunn and say add, now Bob Dunn's in the list. If I come over here and say 25 and 10, I can add them together and get 35. If I change the numbers here to multiply, I get that. So it all works. And this may be a good example of an application you come into where you say, I already have an application running, but I want to add testing. So let's go ahead and do that. And along the way, we'll talk about what is unit testing, why would I do it, those kind of things. So let's start by talking through what is unit testing. Unit testing is the idea that, let's pull up the calculator. This is the really simple one, okay? How do you know that works? The add method. Well, obviously, if you look at it, x plus y returns the correct value. So really simple, yeah, sure, it works. So if it's a little bit more complex of a method, though, how are you sure it works? Well, if you're writing this method, usually what happens in a lot of environments is you write it and then maybe you wire up the button here to just do add and you see if it works. And if it works, great. You go back and you call that good and you go on. But that kind of manual testing, first of all, is slow. Second of all, you might create some test code around it. And then you kind of have to delete it, make sure you delete all the test code. And if there's a bug in the calculation, then what do you do? So it's kind of clunky. And this is the way we used to kind of test code. And in fact, a lot of people still do. They kind of assume it works, or they write little test bits and then delete them, or they have a different application where they just have test code in it, they copy and paste it in there, make sure it works, and then put it in the real application. So unit tests came along and said, well, here's what we can do. We're going to create a project that will have a method that's going to test the add method. And it's going to pass a couple of values in. And we're going to say, okay, we're going to pass a 4 and a 3 in. 4 plus 3 is 7. And so we're going to say, you do 4 plus 3, you should come back to me with 7. And we're going to compare what we think it is versus what it actually is, and make sure the two are the same. That's the really foundational principle of a unit test. It tests one little unit, one piece of work. And so that's what we're going to do. We're going to build up these tests, because then what happens is we can feel comfortable making changes to this method. Because if the test works afterwards, it hasn't changed the functionality. So let's go ahead and see this in action. It'll make a little more sense once we do it. So what we do is we right-click on our solution and say Add, New Project. And we don't go here to the test folder. Now see, we have installed under Visual C#, we have a test folder where we have the unit test project. That would be what we use if we're using the MSTest project, but we're not going to do that. Instead, we'll come up here to Windows Classic Desktop and search for the class library. Just make sure it's the .NET framework, because there is the .NET standard class library. That's not what we want. So Windows Classic Desktop, the .NET framework version of the class library. And this is one of those naming convention things. So what we're going to do is we're going to call it demo library.tests. That's my naming convention. That's a pretty common naming convention. There are other ones out there. But since I am testing the demo library with this test project, I'm going to call it demo library.tests. All right, so the first thing it does is it creates class 1. We'll delete that. So this is just a class library right now. We're going to upgrade it to an actual XUnit library now. The first thing we'll do is add a reference to our demo library, because that's what we are testing. So we need to see it. Next, we'll right-click and say Manage NuGet Packages. And we're going to go to Browse and say, now notice there's NUnit. That's a different testing framework. It's another great one. But I think that XUnit is just better. So we're talking about good versus great here. So let's go with great. So XUnit. We'll install XUnit. We're also going to install a couple more. So we say OK and just wait for it to be done installation. And now we're also going to grab the xunit.runner.console. We'll install that. And again, we'll wait for this to finish installing, which it did. And then finally, we're going to search for xunit.runner.visual studio. And we'll install that as well. Go ahead and check the do not show again, now that I've seen it all 3 times. Okay, so now we have 3 things installed. We have XUnit, we have XUnit the runner.console, and runner.visual studio. Notice that XUnit actually depends on accessibility core, assert, analyzers, and all the rest. These were all installed because XUnit was installed. So that's fine. Don't worry about making sure you know all of those. Just need to know XUnit itself, xunit.runner.console, and xunit.runner.visual studio. That should take care of everything we need. Now what we can do is we can actually set up our first test right away. That'll get our feet wet and kind of see how a test looks. We're actually going to test the calculator, because this is the simplest example we can do. So let's right-click on the demo library.tests and say we're going to add a class. Now again, this is a naming convention. So I'm going to say I'm testing the calculator. I'll say calculator tests is the name of this class. I'll make it public. What I'm going to do is create my first test. Now, calculator is a static class. So I don't need to instantiate it. That can kind of save some of our time and effort. So we have a static method called add. So we calculator.add. So let's add a using statement first. Oops, using demo library. And we're going to say public void returns nothing. Now again, here's another naming convention thing, and this is where people often differ on how you should name your methods. Some people say, well, you should start with should, because you're saying this task should this is what should happen. So should add two numbers together. That might be our test name. I prefer to start with the method name first. So add in this case, because I can see this is the calculator class we're testing. This is the add method. That way, when I have multiple methods that do work on doubles, I don't get confused as to which is which. So I name it first by the method name, then by what's going to happen. So I'm going to say, in this one, simple values should calculate. All right. So what I'm saying is I'm testing the add method. I put an underscore and then I say, this is what's going to happen. The simple values should calculate. And what I mean by simple values is, 4 plus 2 and 5 plus 3 and those kind of things. And I'm going to, let's start off with nothing we're going to pass in. We'll get to that in just a minute. But for now, we're just going to have this method as is. And I'm going to create 3 different sections in here. And this is the general layout of a test. First, we have the arrange. This is where we arrange our values and get things set up to run our test. Next, we have the act phase. And the act is where we do the actual action that we're testing. And finally, we have the assert phase. An assertion is where we say, this is what I expect, here's the actual value, and let's test the two to make sure they're equal. And there may be other ways we can do that, but it's always an assertion. This should be the outcome. So that's the assert phase. So first we have the arrange. Now this is a fairly simple one. So what I do is I set my arrange, at least I'll have my expected equals, let's say our expected is 5. So what my expected is I'm saying this is the value I expect to be returned from the add method. All right, so there's my expected. And then I'll have my actual. That'll be in the act phase. Double actual equals calculator dot add, and let's pass in a 3 and a 2 because 3 plus 2 is 5. So now I have 2 variables, expected and actual. And I like to always have these 2 variables named this because I like to see exactly the same thing every time. So if I come into a unit test and I see a variable called expected, I know it holds the expectation of what should happen. And again, actual it holds what actually happened. So this is a naming convention that's common. It's not fully common. It's not everyone that uses it. Sometimes people kind of shortcut and don't use expected, or they don't use actual or stuff like that. I like to always have expected and actual if I can. And again, it's only if it makes sense. So now we have the assertion. So an assertion can be as simple as assert, which right now, assert doesn't have, there's no assert method yet, but if we hit control dot, we have to add the using statement for XUnit. So assert dot equal. And this is a pretty common one. So the assert dot equal says, I need 2 values, or at least the simplest version. I need 2 values. Value 1 is expected, value 2 is actual. Now notice it's string, decimal, double, and all the rest. So let's pass in first expected, and then actual. All right, so now I'm doing is I'm comparing these 2 values. And what the assert does is the assert says, let me check to make sure these 2 are the same. If they are, I'll have a passing test. So we have our first test set up. But before we go, we have to decorate it. And that's right above the method. We put the square braces. And we're just going to type fact. So a fact is just a test that says, yep, this is a test, and I want you to run it in the test runner. Well, where's the test runner? If we go to Tests, go to Windows, and say Test Explorer. So it says, okay, build your solution to discover all available tests. Let's go ahead and build the solution. And it's still building down here, so that's why I haven't shown up. I only have 2 warnings, that's fine. And it looks like maybe actually those errors mean something for us because we're not populating our tests over here, which is fine. Let's look at the error list and find out why. Let's not panic. So it says the primary reference, the demo library.dll, could not be resolved. Well, that's a problem. You can't get the demo library because it was built against .NET Framework 4.6.1, which is higher than the currently targeted framework of 4.5.2. Makes sense. So what it's saying is the demo library is 4.5.2 of .NET, but I'm sorry, the demo library tests is. But demo library is a higher framework version. So let's go to properties of our demo library.tests. And sure enough, we're at 4.5.2. Let's change that to 4.6.1. We could change it to .2, but 6.1 is fine for us. That way they match. All right, so now let's change that. Let's build our solution again. Build succeeded. Okay, so now we have a test showing up in our window here. Let's kind of expand this window here. Notice how large it is. It says demo library.test.calculatorTest.add. Simple value should calculate. It's quite a mouthful. All right, and we're going to shorten that in just a minute. But first, let's go ahead and run it. So this is our test. To run it, we could say run all, or we could right-click on it and say run selected tests. Either way, it's going to compile our application and run it. Now, I have a working test. It turns green, which is great in most cases. The only danger here is if my test always passes. So for example, if I came to my actual and I put 5 for my actual, instead of saying, I want you to actually do the calculate, and I were to run this again, so let's go ahead and build solution, and we're going to run all again, and it says, yep, that passed. Well, yeah, it passed because I'm comparing 5 to 5. That means nothing. So that is the one danger of writing tests after you have working code, which in this example, we're simulating an application that's already in place that we're now adding tests to make it even better. So that's the one danger, and that's why one of the tenets of test-driven development, which you may have heard of, test-driven development says before you write the code, you write the test. And the reason for that is because when you write the test, the first thing that happens is it fails because there is no code. And so then when you write the code and it passes, then you know that the test is working as expected, hopefully, or mostly that's true, and you know the code is working as expected. So they have what's called red-green refactor. So you start off with a red light, which a red light, let's just simulate that. Let's say 4 here instead. If I were to run this now, it goes red. That's because 4 does not equal 5. So this is a failing test, and it says expected 5, actual 4. All right, we can actually move it up a little bit. So they say their idea is you write this test where it fails first, then you write the code and make it work. And then you go back to the code and refactor. And so what refactor does is it allows us to change the code without changing the input or the output. And so it's basically cleanup. making it more efficient or making it better code internally. But since you have a working test that hopefully is turning green, meaning it's actually working the way we're expecting it to, then you can make any changes you want to the code, because if it turns red, you know those changes are bad. If it stays green, you know those changes are good. At least that's the theory. So that's test-driven development, and that's why they do what they do, because they are also testing their test. Now, for us, since we're working in an existing application and adding testing, we don't have that luxury, and sometimes it's a little aggressive for unit testing. And here's my philosophy. Let's take a quick timeout just to give Tim's philosophy on unit testing. You will find a lot of people out there who are unit testing fanatics, okay? And I don't mean that in an unkind way. I'm just saying they are, everything is precise, everything is test first, everything must be tested. We're going to, if we write a property, an auto property, it has to be tested, which doesn't really make sense since you're testing the .NET framework essentially. But we're going to do that, all the way through. Those people are a little aggressive for my nature. They're a little all or nothing. Now, there's the other side of the pond, which is the people who have never written a unit test in their life. They just write code. Those people could benefit from unit testing. But if you listen to the test-driven development people, especially, or the extreme programming people, or all those other buzzwords that have been thrown around, if you listen to some of those people, and again, I'm broad brushstroking here, but that can get discouraging because it feels like if I don't write perfect tests and if I don't have 1,001 tests, I shouldn't do anything, or I'm not good enough. And so it's, I'm embarrassed to show you my testing library because it has 10 tests in it. Well, guess what? 10 tests are better than 0 tests. 11 tests are better than 10 tests. Most likely. I'm generalizing. So I encourage you to not get caught up in the hype of I have to test everything. I have to have 100% test coverage. And I have to have every layer of tests, because we're testing right now unit tests, but then there's integration tests, and there is end-to-end tests, and there's all these other tests you could do, and there's tons of frameworks and tools and stuff surrounding it. Start off small. Write a test. Maybe you have a method that's a little tricky, and it does some really kind of tricky stuff. Write tests for just that method. Make your life a little easier and keep going. Get the ball rolling, take small steps, get something. Don't feel discouraged because you don't have the ultimate behemoth unit testing solution. Get something to work. It will benefit your code and will make you better as a developer. All right, so enough philosophy. Let's get back to actually testing. So remember I said this is kind of a long name, and it is. So let's go ahead and shorten that a bit. So the way to do that, I'm going to kind of make this window smaller, is to go to our Solution Explorer. In our demo library.tests, we're going to right click. We're going to say Add New Item. We're going to search for JSON, JSON. And let's grab a JSON file. We're going to call this JSON file XUnit.runner.json. Okay, and in here, in quotes, we're going to say method display. We're going to say method. So what this JSON file does is it changes our Test Explorer view. Notice it's actually shorter already. Or it will be, sorry. Let's build this. Oh, you know what? We need to close and open Visual Studio. That's why. Let's do it. This may take a couple of seconds here, but what it's going to do is it's going to allow us to see just the method name as opposed to the whole solution name and the class name and then the method name. So that'll hopefully shorten up our string a bit. All right, so they should appear in just a minute. All right, the one thing I forgot to do, the reason why it's not showing up and changing this, if I go to my Solution Explorer again, right-click on this JSON file, go to Properties, I forgot that it needs to copy to the output directory. So copy if newer. What that does, it actually, when it builds, it'll take the JSON file with us. So let's build the solution. And now we have a shorter, just the name of our method. So add simple value should calculate. So that's a pretty simple one. Okay, so we have this calculator and we've got an add method. So we're going to test to make sure it actually does add. But you know, there are potentially issues with this. For example, what if it returned 5 all the time? Well, then we'd have a problem because we're testing against 5. And this is where XUnit has a feature I really love. So normally we just tag fact on top of any test method, and it picks it up and puts it in our test explorer. Well, we're going to change that. So instead of test, we're going to say theory. Now a theory, what it does is it allows us to pass in data and run a test multiple times with different data sets. So let's start off by saying I want double X, double Y, and double results. Result. Let's actually call this expected. All right, so we have X, Y, and expected. Let's take the expected out, and we're going to pass in what's called inline data. So inline data allows us to essentially populate these 3 parameters, X, Y, and expected, right here. So let's pass in 4, and the next one's going to be, let's go 3 and 7. So 4 plus 3 is 7. I'm going to copy this inline data and paste it again. And this time I'm going to say 21 and 5.25. Because remember, this is a double, which means that it really should add the two together. But what if it's actually doing some kind of rounding? Let's make sure that we have that covered. So it should be 26.25. So you have to do some math here to make sure that your math is right. But now I'm passing in 2 different sets of data. How does this look when we actually build this? I'm going to build this. And now over here in the test runner, I have 2 tests. Notice that it actually tells me the 2 different sets of values coming in. 21, 5.25, 26.25, 4, 3, and 7. So it's going to run both of these. So let's run all. And it's going to test both of these. And it goes, you know what? Nope, they both failed. Why? Well, because I'm not actually using X, Y. So let's use X and Y. So I'm passing in X and Y for my parameters instead. Now let's run all again. And now they're both green. So we have 2 working tests. And in fact, we can add more if we want, just by adding more inline data. Now that's probably good for add, but you know, there might be a case where we have some edge cases. So let's think about double dot max value. Well, max value is the maximum value you can have for a double. So what if we were going to add 5 to that? What should be the result? Well, I'm assuming max value. Let's see if I'm right. The other thing here is when I do build, it shows up here, but I have to come over here then hit run. Unless I click this button right here underneath test in Test Explorer. It says run tests after build. You can also go to the test menu and go to the test settings and select run tests after build. Same setup either way. So now what happens is when I go to build solution, it's going to build it, see we have new tests, and run that new test. Or at least it's supposed to. Evidently, it's not going to cooperate with me. I think this might be to do with the fact that it's XUnit, but I'm not sure. My Enterprise Edition does do this without fail. I always have this turned on. They just run afterwards. Not quite sure why it's not running for me, but we'll see if it kicks in a little bit later. But for now, we'll go ahead and hit run all. All right, so now we have this value also worked. Notice, whoops, a little too big. Let's get a little smaller. So it says, okay, I'm adding these 2 values together. And my expected, let's see if we can't make this bigger. What I'm going to do is I'm going to drag it down to the bottom instead. They really need to work on this whole interface. So it says, okay, the X is this really long value right here. The Y is 5. The expected is, again, this really long value here. And it says, yep, that worked. All right, so we just tested an edge case. All right, I'm going to put it back over here. We just tested an edge case in that normally you wouldn't pass max value through as one of your values to add. But what if someone did? We'll make sure the application doesn't crash when we're expecting, something weird come through. Okay, because if you always test, the simple stuff, 4 + 3 is 7, you're not going to necessarily catch all your bugs. Now, here's the other thing that might happen. You might test this and it all tests fine, you get green across the board. And then someone gives you some wacky value and it crashes your application. Or you have some kind of error, it throws an exception. And you say, well, I didn't expect that. They file a bug report and you go through the bug report, you reproduce it and go, oh, yep. When a person passes, -5 and +5, for whatever reason, it doesn't come out as 0. What you can do is you can create a test that reproduces that. And if you create a test that reproduces that, and you do see that it fails the test, then when you go and change your method, hopefully the current tests that are green stay green, and the one that's red changes to green. If that's the case, you can deploy your fix, and you leave the test in place. Because now you have a test for an edge case that you hadn't thought of. So that's just something else to think through. Now, let's go ahead and test our next method. So we're going to do pretty much the same thing, except we're going to do it for a different method in our calculator class. And we can go on and on with the add method, and I don't want to get too far in depth just because you know now how to test the add method. So just start thinking through, any other edge cases you might feel. I don't feel like I have to cover that in this video just for sake of completeness. But there is one method in here that's a little squirrely sometimes, and that's the divide method. So let's test that. So let's start off, we're going to do a theory right out of the gate. And we'll say that the, again, square brackets, the inline data is going to be, let's start off with something simple. We're going to say 8 minus 4 is 4. Really simple. And our method is public void divide simple values should calculate. Double x, double y, and double expected. All right. So we have our arrange phase. We don't need to do any arrangement because we already have our expected setup, and we're not instantiating a class or anything like that. So now, we have our arrange. You don't have to type this out, but I just want to kind of demonstrate, the different phases for you and kind of highlight them. So now we have our act phase. Double actual equals calculator dot divide x and y. And now we can do our assert, which is assert dot equal. There's a lot more options in here, but we're going to do equal. Assert dot equal, and we're going to say expected actual. And that order is important, even though it's an equality check, because when we look at it in the Task Explorer, we see the x and the y values and what it should have been versus what it was. And so if we get those flipped, we might see it should, 4 plus 3, we're saying it should have been 7, but it actually was 6. We want to make sure it says we expected 7 and got 6, not we expected 6 and got 7. So just make sure you put them in the right order. So we have a test now for divide. Let's run all on this. And we've got an error already. All right, let's find out why. So the error is we expected 4, we got was 2. Well, actually that's because I was thinking subtraction. 8 minus 4 is 4, but 8 divided by 4 is 2. Our test was the problem, not the actual code. Just make sure you think that one through. Again, this is where test-driven development people go, yep, this is why we develop our tests first, so we make sure that our test is failing for the right reasons. But yeah, so just make sure the test is right, but then go and check your code next. So we have a working test in theory. Let's go ahead and build our solution here. Oh, and it says, oh, not run. So let's go ahead and run all. And we've got a green test. Now, the other thing we have right now is we've got this kind of mishmash bundle. We can set up grouping by. We can say group by class or by namespace, duration, outcome, traits, project. Let's group by class. Right. For right now, it still groups into one group because we're only testing the calculator. That'll come into play in just a minute when we expand outside the calculator. But now let's look at an edge case. Now we could either test it right here, which probably isn't the right place to test it because I called this simple values should calculate. But let's copy this entire thing. And instead of simple values should calculate, we're going to test divide by 0. And we're actually going to make this a fact because we don't need to pass in 8 different things to divide by 0. We can just do 1. So we're not going to pass anything in. And instead what we're going to do is in our range, we'll actually set up our expected. And here's the first place you have to ask the question. What do you expect to get when you divide by 0? Well, if you expect to get 0, which isn't mathematically correct, but if you expect that, then we'd say 0. I do know that it's going to return infinity because, I guess, reasons, I'm not sure. It used to throw a divide by 0 error or exception. So the question of what you expect depends on your logic. For this particular case, I'm going to say I expect 0 back. Now, again, not the greatest math logic. I just want to cover exceptions later. So let's just say that I expect it to return 0. That's my personal business logic. So let's just say 15 and divided by 0. All right, so that's my act. I'm doing a division to get the actual value. Let's see if the two are equal to each other. 15 divided by 0, I expect 0 back. Let's go ahead and build this. We get a new test. We just say run all, or we can right click and run that one test, and we get a failing test. We expected 0, we got infinity. Well, I'm not even sure how I would define infinity as a value to be expected against. And I'm pretty sure that caused some problems when I try and use infinity then to add 5 to it. So this is one of those cases where, okay, we've got a bug in our code because our business logic says we should expect to get 0 back. And this is one of those cases where if you have business logic that says when this happens, this should be the outcome, that's a great place to put right in a test. So calculator, we have this divide method. Well, if we're dividing by 0, we need to return 0 instead of this action. So let's do this. We're going to refactor. Surround with if y is not equal to, not equal to 0. I almost got into my SQL call there. SQL is a greater than or less than, but with C#, it's not equal. The bang or the exclamation point and then the equal. So if y is not equal to 0, return x divided by y. Else, I'm just going to make sure I note that because the next program coming along goes, that's just stupid. So I'm going to say, yeah, but the boss told me to. So return 0. So if y is not equal to 0, do division. But if y is 0, return 0. Now, let's build our solution and run all of our tests. And now we have a working test. So I put that business logic in when I had a failing test, and I made the change, and now all my tests pass, not just making sure it divides by 0 properly, but also the simple value should calculate. So now I feel comfortable making that change because I didn't disrupt the normal stuff, and I add the logic for the edge case. So that's why, writing good tests makes you feel more comfortable, more confident making changes to code. Because if an intern comes in and says, oh, I can fix this, and they go ahead and fix this method, if you don't have any tests, how do you know that it worked? Well, you actually run the application. So that can very easily miss these edge cases. Now the intern makes a change, and you just go ahead and say, well, push the run all button. If you get all green lights, you're good to go. If you don't, you screwed something up. So go back to the drawing board. So that's one of the benefits, one of the big benefits of testing. So now I have some inline data with theories, and I have a fact test as well. Now let's go and add another test. This time, let's test something a little more complicated. Let's start with my examples.cs first, because this one is the exception. So this one method, again, it's a static example, a static class and a static method. So what this does is it simulates loading a text file. So you give it a file name. If the file name is the length of it is less than 10, it throws a file not found exception. Otherwise, it returns the string the file was loaded correctly loaded. So let's test this example. All right. So we're going to go to our Solution Explorer. we're going to right click on demo library.tests. We're going to say add new class, and we're going to call this class examples tests. Make it public. And now we'll create our test. So let's do this. Let's create a fact test first. And I'll show you why we're going to keep it as a fact test, but let's start a fact. And again, we have to add our using XUnit to the top. And we'll also have to add a using statement for demo library. So our name of our example method is example load text file. So just like here, where we start, oops, not here, just like here, where we say the name of the method and then what it does, we're going to do the same thing for our example tests. So public void, we don't return anything with tests. I'll start with the method name, example load text file. Let's just pass in valid name should work. Okay, so as long as you pass in a valid name, it should work. So what we'll do is we'll start off by saying, here's our assert. So, expected. Expected equals, and then let's just say, you know what? Let's not even do an expected. I'm going to show you why in just a minute. So let's get our string actual equals example. Oops. This is in the examples. There we go. Examples, example load text file. Okay, we're going to pass in a file name. This is a valid file name. Doesn't matter what it is, just a string longer than 10 characters. We're going to say assert dot, and we're going to say, there's got a lot of different options here. We have matches, equals, not the same, null versus, we can say not null. There's a whole bunch of different options here. So we can say true. Let's go with true. This is a fun one, because it just says test this condition is true. So actual dot length, because it's a string, don't forget, is greater than 0. Meaning you actually return some kind of string. It doesn't matter. We could go ahead and copy this string over and make sure that it matches exactly and do an expected and actual, but that seems kind of fragile to me. Instead, we get to show off another one of our options here, which is the assert.true. So you can look through this entire library. There's tons of stuff in there for other assert type statements, including null and comparing two values and doing some other options. But assert.true works in this case. We're just going to say, hey, make sure the length is greater than 0 for the returned value. So it's a really simple test. Let's build our solution. Notice it now pops in down here because it's under this class, because we did that sorting or filtering by, not filtering, but grouping by class instead of by, I believe it was outcome. So we can right click on this and say run selected tests. And we get a green light, meaning we are good to go with our basic example. Now, one more thing to point out real quick is, what if you wanted to debug why this wasn't working right? Well, you can throw a breakpoint right in there. If you were to run this test, though, it just ran, and we didn't hit that breakpoint. And the reason why is because run skips over breakpoints. But if you right-click and say, nope, I want to debug the test, then we hit this breakpoint, it pops right out to it. Wait for it. There we go. It pops right out to it, and we can actually inspect the value. So in this case, the file is correctly loaded is the returned information. And the length is 30, which is definitely greater than 0. We continue, and it runs on its merry way. So we can use breakpoints in that way, just like you would in the actual application, to make sure that things are working the way we expected, making sure that we know why a test is failing. So let's copy this and create another fact. But this one, we're going to say, instead of valid name, we're going to say invalid name should fail. All right. So an invalid name should fail. Remember that it checks for a length of at least 10. So anything less than 10, it's going to throw an exception. So how do you check for an exception? Well, what we're going to do is we're going to cut this code down to just our actual check. I'm going to do a Control X to cut this. And we're going to say, just start with assert. Assert.throw. And we can actually specify, throws, I'm sorry. We can actually specify the type of exception. So the exception that we're looking for is the system.io.filenotfound exception. So let's actually add a using statement for system.io. Using system.io, that shortens our call. So this is a file not found exception. And that's inside of these angle brackets. All right. And so then what we do is we have to actually call the method, but since it's going to throw an exception, we can't just call it and put the value into, say, a string, because that would cause an exception. We don't want an exception where it's going to blow things up. We want to capture that exception. So this assert.throws actually has like a try catch in there, and it's going to check to make sure the exception is this exact type, and then do a comparison and all the rest. So we have to actually run a method inside of our parens here, which means we have to get a little tricky. And so do open close paren again, and then equals greater than, and our call. So what is this doing? Well, this is actually saying, I want you to pass an action in, okay? So if we mouse over here, it says action test code. Notice right there. So this is an action. This right here. What it's doing is saying, here is the parameters you pass in, and then here is the actual call. Okay, so it's the actual call. It's a little complicated, I understand, but basically just know that open close paren, your lambda expression, and then the actual call you want to make, the method call you want to make. So that's it. And what's going to happen now is it's going to run this. If it throws an exception, it's going to check to make sure it's a file not found exception. Let's see if this actually works. Go ahead and hit build. We have this new test here. Let's do run all to make sure that all of our tests are run. And now, yes, it did work. So we actually had an exception. If I were to change this exception, let's just call it, let's have a generic exception instead. And if I were to run these all again, it'll actually fail, because it says expected system.exception, but it actually got system.io.filenotfound exception. That's a different exception. So that's why it failed. So now it's checking to make sure that it's the correct exception. All right. Now there's one other thing we can do here, and that's at the very beginning. Before we, there we go. We can actually pass in a parameter name. What the parameter name does is it allows us to say, here is the parameter that caused the problem. Say you have 5 different things passed in, and you're checking each one to make sure that it's valid information. And if one is not, you throw an exception. But which one was it? Was it, say it's the first name, last name, email address, phone number, and age. Well, which one of those properties was the problem? If any one of them can throw an exception, which one was the ultimate problem? Well, we could pass in the exception name right here, a parameter name. So we could say, well, the parameter name is file. I'll just put file here. Now here's the problem. This right here, the file not found exception, that exception won't actually work with the parameter name, but an argument exception should. Yep. So that would mean you'd have to make sure that your item is returning an argument exception. But let's go in here and refactor this. Maybe if the file length is less than 10, we should, instead of throwing new file not found exception, we throw a new argument exception. We can actually pass in which argument it was. Okay, which parameter it was. So that's number 4 out of 5. So we can say the message was, the file name was too short, and the parameter name is file. And again, that's a string, so you have to actually type the name out exactly. But if we did it this way, then we can actually test to make sure that the correct parameter is the one that caused the exception. So if we're testing this, we might actually test it 5 times. If we had that object with the 5 different values. We test it once, the first name it's invalid. And then say, make sure that the argument exception throws it on the first name, not the last name, not the email address, the first name, and all the rest. So just to make sure, just to show this does work, if I said file 1 instead, and I run these tests, I've got a failing test because it says I've got a problem here. And it says, okay, assert.throws failure, expected type of system.argument exception, actual no exception was thrown. Well, that's interesting. Let's find out why. Well, because we didn't say throw. When I came down here, I actually accidentally blanked that out. So throw new argument exception. Let's try it again. So this is where tests really help you. That little typo caused me a problem. So again, the test failed, but this time it says, I expected that the failure would be on file 1 parameter, but instead it's on parameter file. Well, you go, oops, I mistyped that. It really should be on the file parameter. We run this again. Now we've got a working test. So we're actually testing that something throws an exception, which is good because exceptions do tell us information. They do say you can't do this, and that's a good thing. They want to stop the application, but we can also test to make sure it really does stop the application. So there you saw that we can throw an exception and catch it. We can actually, if we have certain exceptions, not all exceptions, but certain exceptions like the argument exception, we can actually check which parameter was the problem. And you saw how when I went in here to make a modification to my code, I did something that I shouldn't have done. I didn't throw the exception. And that little typo would have allowed my application to work as I thought I expected unless I actually tested this file.length is less than 10. Fortunately, I had written a unit test for that, and the test failed. And it says, nope, what I expected to have happen, which is an exception, didn't happen. I fixed my code, and now it works as expected. So really easy to see how unit tests can make your life easier. And again, I could have 100 tests for this little project. I have 7. But those 7 have helped me already. So again, getting back to what I talked about earlier, just because you don't have all 100 doesn't mean that you're not getting benefit out of unit tests or that you're somehow not measuring up. do what you can, make it a little better every time. Maybe if you write new code, write tests for it first, or write tests for it at some point. But don't just ignore it. At least make it a little bit better every time. Okay, so let's look at the big one now, and that is the data access class. Because this is where people kind of, stop, or, unit tests kind of break down a little bit because they get into the real world, and the real world is complicated and messy, and it's hard to test. And I say it's hard to test because look at this. Let's just take the add new person method. What does it do? Well, not a whole lot, yet something happens. We get all the people from our text file. That's the text file right here. We add a new person to that list, and then we grab each of those lines. We create a line for each of those people, and we write all those lines back to the text file. So essentially, we add the person to the list and write everything back to the text file, overwriting everything. Do you see a problem with running tests on this method? I mean, if I run a test 100 times, every time I build it runs again. Every time I do something, it runs again. Well, if I do that, we're going to be adding that person 100 times to the text file. What if we had something in place where we're saying, make sure that person is not already in the text file? Well, then my test would only work the first time, and then it'd fail every time after that. So that's a problem. I mean, there's so many problems here with testing this method. And part of the reason why is because this right here is not one unit of work. And that's where over the calculator, the add method does one thing. Even the divide method that has a little more logic to it does one thing. It divides one number by another. So when we're talking about data access, look at what it does. It gets all the people. Then it adds the person to the people. And then it takes all the people and it converts them to a list of strings. And then it writes everything to the text file. That's about 3 or 4 different things that it's doing in that one method. Well, first of all, that kind of violates our single responsibility principle. The single responsibility principle says that a method should do one thing. That's its job, one thing. So we should really be breaking this method apart. And that's where unit tests really help us, because unit tests are all about those single things, the single responsibility methods. A unit test really shouldn't span a large area of code. Now, there is some debate on what a unit of work is. In my personal opinion, a unit of work is any set of work that doesn't access anything external. External meaning a database, a text file, the web, those type of things. That's all external stuff. So a unit test would be on anything that does not access external stuff. An integration test would be on accessing that external stuff. And then our end-to-end test would be for, if you start in the UI and they actually even capture the UI clicks and then watch what happens all the way through the process. So it's creating and saving a user. That'd be an end-to-end test. But today we're doing unit tests. So how do we make sure that we can test this add new person method? What we're going to do is we're actually going to change how this new person method is laid out. So let's start and kind of break this out a little bit. Let's create a couple private methods. And actually, I'm going to make them public. And this is one of those things where it's going to be a little bit of a debate on how you do this. Because the next question is going to come up is, I want to make these private methods, but I want to test them. How do I test private methods? There will be ways to test private methods, but my personal opinion is you shouldn't. Because private methods are not exposed anywhere. What you should be testing, in my opinion, is those public access points. Whatever happens behind the scenes, all they care about is input and output. And that's the public methods. So in this case, I'm actually going to make methods public that I might not otherwise make public, but they do a job, they do one job, and so it's okay. Now, I could also create a separate class that supports this class, and that class could have all my public methods that do those one bit of work. That way I could keep this class clean for public use, and yet I have all the rest of my methods somewhere else. That might be a good solution if you're concerned about having all these methods be exposed. But I would make these public because they are, like I said, doing work, one bit of work. So let's make a public static void add person to people list. All right, we're going to pass in our list of person model. We'll call it people. And we're also going to pass in our person model person. All right, so what does this do? Well, all it does is it says people dot add person, which seems kind of ridiculous, okay? But, and that's what we do right here. So let's get rid of that line. But the reason why I'm going to do this add person to the people list is because I want to do some checks to make sure that maybe the first and last name of this person object is valid. So before I add a person to the people list, I want to make sure that this thing is valid first. All right, so now I'm going to do is say add person to people list. I'll pass in my list that I already have and the person I just got. So all this method does now is, right now it just adds the person to the list, but eventually we'll have some kind of checks in place to make sure the person is a valid person. So we've now taken one of the responsibilities off of this method right here, and we've created something we can test. Now, let's look at this right here, because I think we can take care of converting our people list over to a CSV list instead. So let's do public static void. That's actually, you know what? Let's return a list of string instead of void. List of string. Convert models to CSV. We'll pass in our list of person model. We'll again call it people. So we're going to pass in our people. We're going to get back a list of string, because that's what we're capturing up here. In fact, here's what I'll do. I will cut this out. I'll paste it in here. The only change I'll make is I'll call it output. I like to call the value going back out, I like to call output, so it's very clear. And then I'll grab this code right here and cut it out, and I will paste it in down here. So now I'll take this people list. For each one, I'll create my CSV. And again, I'll change that to output instead, and I'll return output. So now I will say convert models to CSV people, and I'm going to use that for actually writing to my text file. Now I could just put it right in here, but I'm actually going to capture that as a list of string right here, because if I want to debug something, I have it available versus passed inline right here. So now I've kind of broken out this into a couple different pieces. So I've got the, first we're getting all people. Well, we're going to test that later. That's going to be something else we test. But we don't need to actually do anything more with that because it's actually its own method. Then we add the person to people list. We're going to add some code there. But the next step is to convert that to CSV. The next step is to write that. So this method right here, add new person, is actually composed of 4 different method calls. Well, we don't need to actually test the actual caller necessarily. I would probably test this when I do integration testing because I'm actually integrating with the text file. So that's what I'd probably look at doing that testing. Now, some people might say, well, you can actually test this. What you do is you have some kind of mocking framework or fake or a shim or something like that. And what that does is it would replace the actual, let's find it here. Let's look at get all, well, it's right here. File.write all lines. This is a Microsoft bit of code. Well, we could write a shim that says, okay, replace this method right here with our own that pretends to be this. And we could do that. And there's, like I said, you can go way down the rabbit hole of mocking and shimming and writing fakes and all the rest. But it makes me a little nervous. And here's why. Because when you do that, you gotta be very careful about what you're actually testing. You can write lots of great tests that have the green check mark, but that's just because you're writing this shim that does what you expect it to do, and that's all it does. It doesn't actually simulate the real world of what happens in this write all lines. So just be careful of that. I've seen some people that have felt like they had great tests and they had all these fancy things for simulating databases and the web and the .NET calls and all the rest. And they have all this complicated passing things around, creating all these objects and all the rest. And they're not actually testing real code. They're testing fake simulated code. So what I prefer to do is I prefer to say, well, I'm going to test this in integration testing where I'll actually use an actual text file and we'll try it there instead. And so I'll skip this for unit testing. And instead, I will test this method. I'll test this method. I'll test this method. And since I don't have anything to do here, I'm not going to test this method. But this is a Microsoft method. I'm going to trust it. So as long as I've verified all the information going into it and all the methods up to it, I think I should be okay. So that's my personal opinion. That's how I do it. For most cases, is I try to work around not having to do the mocking or creating the fake objects. So again, personal opinion, it's up to you. Just don't get overwhelmed and not do anything. Okay, so let's write a couple of tests for what we have so far. So we have this add person to people list. Okay, so let's test that. All right, so I'm going to copy this method name. So we'll use that in a minute. And we're going to right click on demo library.tests and add a new class. And we'll call this the data access tests. We'll make it public. And our first test will start off, just assume fact, unless you have a reason to assume otherwise. And we're also going to add our using statement using demo library. Let's say public void. It's the add person to people list. And these method names can get really long. And it's okay that they get really long because they're descriptive. Now, if you feel like, yeah, I want to do something a little different, that's fine. Like I said, some people don't even put the method name. They just put what it should do. So under example test, you might see should fail on valid name or should work with valid name. So that can work, but like I said, that's for example load text file. What if we have another one for example write a text file? Well, then we've got a problem because that also has should fail with invalid name for that as well. So you have two tests with a similar or same name. So that's why I like to have these method names here. It does make them long. I'm okay with that. So add person people list should work. All right. And so what we'll do is we'll start off with our setup, which that's our expected. So our expected is going to be a person model. All right, add the models. So actually that's not expected. It's going to be one of our new value. New person equals new person model. Let's say our first name is Tim and last name equals Corey. So create a new person model, and now we have to create a list of person model. And we'll call this people equals new list of person model. Okay, so what we're going to do now is we're going to say data access dot, and we're testing the add person to people list. So add person to people list. And this returns a void. That's why I'm not putting it into actual. And this is where it gets a little tricky. And I'll show you what we're going to do in just a minute. It makes a little more sense. This is where this is a little more of an advanced case. Not super advanced, but a little more advanced. I want to show you it because this is what you're going to run into. It's not going to be the neat and clean calculator example. And that's a pretty common one you see in tutorials. The problem is that the real world, bites you as soon as you step out the door of trying to use unit tests like this. Okay, so we're going to kind of work through how we set this up, maybe even refactor this test. But let's set it up first. So we pass in a people list, which we're passing in the one we just created. Now, it's going to add this person to this list. But since a list is an instantiated item, it's a reference type. And what a reference type means is that when over here in data access, I add a person to the people list, it's going to change the list over here in my class. So it's the same list in both places. We don't copy it when we make it into a parameter. That's one of those C# object-oriented things you kind of need to understand. When you pass around objects, you're not copying them. You're passing around essentially their reference. And so it's kind of like you're passing around the address to the same house. Okay? So each instance is its own house, but when you pass that instance around, you're just passing around the address. And so everybody points to the same address. So, all right. So when I say new person, that's going to add this person to this list. So what I can say is assert dot true that people dot count equals 1. Because the list started off with nothing, but you, in theory, added this person to the list, therefore the count should be 1. Here's another thing you can do with a unit test. You can do another assert. Assert contains, so let's grab the a person model and say the person model is new person, and it's in people. So what this contains does, it says, okay, I want to make sure that you have a person model in you that is this exact object. Okay, so it's going to essentially look through this list of people and see, do you have a new person? Which is this one right here with, Tim Corey. If you do, then it's going to pass, and if not, it's going to fail. But check this out. I have 2 assert statements. That's fine. Now, some purists, again, will say, nope, 1 assert statement per call. But the reality is I want to check 2 different things going on with this particular test. Because, yeah, maybe you added a person to the list, and so the people count is now 1, but what if you just added a blank one? What if you didn't actually take my new person and add them, you just created your own and added it? It would still be 1. So I want to check to make sure the count is 1, because that's a good valid check, but I also want to make sure that the person that was added is the one I sent you. So sometimes your unit tests will actually have more than 1 assert. And that's okay. And it will only pass if both of these asserts are true or they work. If not, then it will say which one failed and why. So let's go ahead and build the solution again. We should have 1 more test. All right, so now we have expanded. Oh, there we go. There's our data access test. It's not been run yet, so let's go ahead and run the selected test, and we get the green check mark. Yes, it worked. Now, let's test what if we send bad data. In fact, let's do a theory. All right. So we're going to send data in, and we're going to do inline data. Now, just to point out, I'm doing inline data. There is the opportunity to pass in data from other data sources other than inline data. You can pass in member data. You can pass in data actually from a SQL or from Excel or CSV or text file. There's a lot of different ways you could do it. Some of them baked right into XUnit. Some of them you have to actually create your own loader. But and there's examples on the web for doing that, and even on XUnit's website, which is xunit.github.io, I believe, or something like that. Just Google XUnit, XUnit. Probably the first example will be their page. They have great documentation on getting started. I wouldn't say that they're the full featured documentation necessarily, but they at least get you started in a lot of different areas in a lot of different scenarios. But for this video, we're already long enough. I just want to do inline data. So with that being said, I'm going to pass in the first name. So let's pass in Tim. And the last name, let's pass in nothing. And I'm going to say that the bad parameter should be the last name parameter. We're going to do that parameter check thing. Okay? And now we're going to say string first name, string last name, and string the parameter that is not working. Okay? So now we have our inline data. So, and it's called should work. We're going to say instead, that's why it's giving me the error, should fail. Okay, so we're going to check to make sure it fails, and we're going to figure out why it fails. Okay, so we've got this set up. Instead of passing in Tim and Corey, I'm going to pass in my first name parameter and my last name. We're getting off a screen here, so let's shrink this up for now. And my last name. But we're going to pass in bad data here. In fact, let's pass in another inline data just to make sure we check both cases. We'll pass in nothing for the first name, and we're going to pass in Corey. and the bad parameter is the first name. So what we're expecting here is that if you pass in nothing, an empty string for one of the parameters, it's going to throw an exception. So instead of, again, there's no asserts because we're expecting an exception. And if we don't get an exception, then that's a whole nother issue, and that'll actually fail a test still. So let's cut this out. We're going to say assert.throws. And this should be a argument exception. And the parameter that's going to fail is called param. And the code to test, let's again open close paren, equal greater than, and then our call. So this is supposed to fail. It's supposed to throw an argument exception. And we're going to make sure that the argument in question that's having the issue is whatever we said was the argument. So let's first make sure that this doesn't run. Okay, it should fail. So I said run all. And yep, we've got 2 failing tests because it says I expected an argument exception. I actually got no exception thrown. And the same thing is true for the other one. So it ran both inline tests and said, nope, they both fail because they didn't throw an exception. They did not throw an exception, even though we expected one. Which now I can go ahead and refactor my code. I'm testing it to make sure it works the way it's supposed to work when you pass in good data. And now I have a test for bad data, but that test is failing. So I can come over here to my data access. This right here, I can say, well, you know what? I should check that first name. If person.firstname, actually, you know what? String, I always do this backwards. String.is null or white space. Person.firstname. So what that does is it checks to make sure it says, is this null? Or is it an empty string? Or maybe it has even spaces in it, but just spaces. Just spaces is still invalid. So therefore, it's going to say if it is true that it's null or it has just white space, we're going to hit this code right here. This code is going to say throw new argument exception. And the argument exception is going to say, we're going to say you passed in an invalid parameter. And the parameter you passed in is first name. So even though it's actually inside the person object, we're not saying the person parameter, we're actually saying the first name inside the person object. And that's okay. We can do that. Now I haven't done anything for last name. Let's run this right now and see if we get a passing test. And we do. We now have 2 passing tests and 1 failing test. The failing test is for last name. So let's do this exact same thing. Now, I'm usually opposed to copy and paste because, watch this. Oh, let's check the last name. So, whoops, Control J, go get the last name. Great, I'm done, right? And so I hit the run all. And it's going to run, and it's going to go, nope. All right, and watch. Okay, we still have an error. Now the error changed. Expected last name, but I got first name. Why? I copied and pasted. And when I did, I changed the one parameter to last name, but I forgot about this one over here. That's why I hate copy and paste, because it causes those weird issues like that where you miss, especially if you have 8 different places to change it and you change it in 7, that's a problem. Okay? So with unit testing, I was able to catch that error. I wouldn't rely on unit testing for that, but it is a nice feature that it says, oh, nope, you're close, but you still don't have it right. Now I've made my change again in my method, and I run it again, and now I have all green tests, which means that my work here is done, or at least mostly done. I could refactor. I could say, well, let's see if we can change this up so that it's a little more efficient, or something like that. Now that I have 3 green tests, if I make any changes to this, I can just run the tests again, make sure they all pass. If they do, I'm good to go. If they don't, I have to rethink my refactoring. All right, so what I'm going to do right now is I'm actually going to stop here. Now, there's a lot more work to do yet in setting this application up to have full testing. But here's what I want to do. The way you get good at something is not to watch videos. The way you get good at something is by doing it. Now, watching videos is important. I watch videos all the time to upgrade my skills in certain areas. But the way I really lock in those skills and the way I make sure that I understand those skills is to actually do the work. And so what I'm going to do right now is I'm going to leave this as it is. Now, I have done some work for you. I've got, for example, this method right here, convert models to CSV. It needs to be tested because you need to make sure that when you pass in certain people that you get the correct list of string back. So if you pass in just Tim, Corey, and Sue Storm, you should get back 2 entries in the return value. The first entry should be Tim, Corey. The second entry should be Sue, Storm. You can check all those data points. You can check to make sure it's returning 2 people or 2 entries in your list of string. All that kind of stuff can be tested. I'd probably do a fact-based test, but it's up to you. So that needs to be tested. Then we have down here the get all people, which does a number of things. It reads all the lines from the text file, which, again, this is a Microsoft thing. We're not going to shim that out. So therefore, we're not going to do anything here. But this could probably be brought out into a different method. Taking the file contents, which is a list of string, a string array. Take a string array and splitting it up and creating a list of person model. Well, that right there could probably be tested if you put it in a different method. So create a method for that and then test that method. Then go in here to the calculator. Test the rest of these. Try out things like the double max value and double min value, and what happens when you add a max value and a min value, or what happens when you multiply a min value or max value times a max value, and all that kind of stuff. Create unit tests for it. And then if there's any other methods that you go, you know what, I'm not quite sure how I test that, or I want to try testing that, you can put it in the examples class. So create a little method, put it in the examples class, and then see if you can test it. Okay? You don't actually have to wire it up to any UI. Just test it in the test class. So create a new test in the test examples test. Okay? So try all that out, kind of get your feet wet with unit testing, expand your knowledge a little bit, take an existing application and refactor it, and add tests to the existing application, and then maybe even add new code and test it as well. Maybe if you're going to add new code, try out the test-driven development style of create the test first, have it fail, add the code, make it pass, and then refactor it, and see how you like it, and see if you can start doing it and if it feels right to you. All right, so I want you to try that out. So to do that, you're going to have to go down into the description and click on the link that has that takes you to my blog, and it will have the download there that you can go ahead and download the source. And I'll leave the source as it is right now. So we'll have a source As it is with existing tests working, you can make sure all the tests work for you and then start adding your own tests, okay? So that's your homework. I want you to try it out. Get your feet wet. Let me know how it goes. Let me know if you have any problems or any questions. Leave those down in the comments down below. And good luck. So I hope you've enjoyed this. I hope you've learned a little bit about unit testing. I hope you take my advice that if you're not unit testing now, get started, but don't get discouraged that you're not at the top of the mountain. Just take 1 or 2 steps every day. So just kind of move yourself towards the top of the mountain, but don't get overwhelmed with, the crazy complicated end of unit testing. Start with a very simple end and help yourself out and grow. The more unit tests you create, the better you will be not only at creating unit tests, but also the better you'll be at writing code that's testable. And while I'm never a fan of doing something just because, to fit into a mold, testable code is one of those exceptions, because testable code is actually focused on a single responsibility principle. The idea that a method should do one thing. So maybe you don't test every method because some methods are talking to, .NET framework stuff. But for the most part, you're testing, the methods that are doing the one thing that's the actual logic of your application. So I really like that because it does force you to think about, how do I only do one thing in this method, not a ton. So it is definitely a useful skill to have. It's pretty common in the industry to have unit tests in place. Some companies will even say things like, you can't check in code until it's fully covered or mostly covered by unit tests. So the better you are at this skill, the more marketable you will be as a .NET developer. So I hope you enjoy it. Definitely practice, practice, practice. And as always, I am Tim Corey.